Miss Brown, you fell asleep again.
Oh my goodness. I need to go get coffee. Do you want to go get coffee?
Yeah, let's go get coffee.
Let's go get coffee. Well, the coffee place that I want to go to, we can walk there. It's 1.5 miles away. Oh shoot, but I left my wallet at my friend's house. So I'll take my bike, I'll bike to my friend's house, and then I'll bike to the coffee shop. So you'll walk 1.5 miles. I will bike 5 miles. Let's see who gets there first. All right, so here's the thing. I'm going to bike to my friend's house to get my wallet, and then I'm gonna bike to the coffee shop. I'm gonna have to go a total of 5 miles. Meanwhile, my sister is going to be walking 1.5 miles to the coffee shop. Now, I can ride my bike at a pace of 20 miles an hour, whereas my sister, she's gonna be walking at a pace of about 3 miles per hour. So I'm wondering who's gonna get there first. All right, see you there. All right, so let's think about this mathematically. If I go, Miss Brown is going 20 miles an hour. I'm going 20 miles per hour, and I have to go 5 miles. Well, let's talk and compare that to Daylin, my sister, who is going only 3 miles per hour, but she's going 1.5 miles total. So what I can do first is find a unit rate and think, if I go 20 miles per hour, well, how long is it going to take me just to go 1 mile, and then multiply that by 5? So I can say that right now I'm at miles. My ratio is miles per hour. Well, I know an hour is how many minutes is an hour, because I'm going to have to split it up. And at 1 hour is 60 minutes. So my ratio is 20 miles every 60 minutes. I'm going to rewrite this. So 20 miles per every 60 minutes. Well, I just want to see 1 mile for 1 mile. So how much will I go in 1 mile? How much time does that take me? And if I want to create an equivalent ratio, I think, well, 20 divided by 20 got me to 1. So 60 divided by 20 is 3. So I could say that for every 1 mile, it takes me 3 minutes. So for 1 mile, it takes me 3 minutes. So I want to say, how much is that going to take me if I want to get to 5 miles? How long will that take me? Well, 1 times 5 is 5, so 3 times 5 is 15. So here, I just found out that in 15 minutes, I'll bike 5 miles. So it took me 15 minutes to get to the coffee shop. Even though I had to go farther, let's compare that to Daylin. So Daylin is going at a speed, Daylin's going at a speed of 3 miles per 60 minutes per hour. And I want to say, okay, well, if I want to get, how much time is she going to take to go 1 mile? Well, 1 mile will be equal to, 3 divided by 3 is 1. So 60 divided by 3 is 20. So to go 1 mile, it takes her 20 minutes. So she's walking pretty slow. So to go 1 mile, it takes her 20 minutes. And if she goes 1.5 miles, well, that will be 20 minutes plus, so that's 1 mile plus a half of that, a half a mile. So half of 20 is 10. So 20 minutes for 1 mile, 10 minutes for half a mile. That's going to take Daylin a total of 30 minutes to get to the coffee shop. So I get there in 15 minutes biking 5 miles. She gets there in 30 minutes by walking 1.5 miles. I clearly get there faster. I actually get there in half the time that she does. You guessed it. I've been chilling. And there she comes.
Wow.
Tired from all that walking.
Oh, yeah.
Woo! So I made it first. Congratulations to me. Yum. So if coffee is $2 and 1 bagel is $1, my sister Daylin got 2 bagels and a coffee. She also had a 60% off coupon. Now together our total was $4.60. So I want to see, can you figure out what did I buy at the coffee place? What did I buy? All right, so again, we can think about this mathematically. So Right now, I know that Miss Brown buys something, but we don't know what she buys. I know that Daylin, my sister, buys 2 bagels and 1 coffee. Now, each bagel is $1. Each coffee is $2. And she buys 2 bagels, so 1 bagel plus 1 bagel plus 1 coffee, I could say is 1 plus 1 plus 2. So Daylin she buys $4 worth of stuff, but she has a 60% off coupon. So I think, well, what is 60% off of 4? What is 60% of 4, which is really 0.6 60 hundredths times 4. And 60 hundredths times 4 is going to give me, this is $2.40. So if she spent if she bought $4 worth of things minus her $2.40 coupon, well, that means that she only paid for a total of $1.60. Now, if Daylin paid $1.60, and I know that my cost plus Daylin's cost equals a total of $4.60, well, I want to think of how much money did I spend. So to do that, I can do $4.60 minus $1.60, which equals $3. So I spent $3. So I look back at my combination, and there's actually 2 different things I could have done. Who knows? I could have bought 3 bagels. Because that's 1 plus 1 plus 1, which would equal the $3. Or I could have gotten a coffee plus 1 bagel, which would be $2 plus $1 to equal $3. So here's actually the 2 different options, and I'll tell you right now, I bought a coffee and a bagel. I don't need 3 bagels, and I love coffee, so this is actually, this is what I did. All right, so the next thing we're going to do is my sister and I are both going to paint the same canvas using the same brush, but we have different stroking speeds. I stroke super fast, and I stroke this at 240 strokes per minute. 240 strokes per minute. Where Daylin comes and she's stroking at 120 strokes per minute. Okay, so really the question here is, if I'm stroking at 240 times per minute, I want that to equal, I want to know, when is that the same amount as Daylin, who's stroking 120 times per her minute. So I can use 2 different variables and say this is x and this is y. There is a ordered pair, x comma y, that will satisfy and make this equation true. So one way of solving this is saying, here when x is 1, I get 240. After 240, I can double this and get 480. So that right now is when x is 1. This is when x is 2. And over here I want to say, when is this going to equal the same amount over here? Well, if y was 1, I would get 120. But watch, when y is 2, I double this and I get 240. So they share this common multiple of 240. You can say that this is finding my least common multiple. So I know that when x is 1, so 240 times 1 will equal 120 times 2. And this is x, this is y, so I could say that the solution to this would be 1, comma 2. This is the solution to my ordered pair. When we would be stroking at the same amount of time when I've been stroking for 1 minute, and it will take her 2 minutes to catch up. She'll have to stroke 2 minutes to be at the same amount that I have.